Hello students. In this video we will talk about motion of objects under the influence of gravitational force. So in this video we will study about the motion of objects under the influence of gravitational force. This we know that each and every object in this on the earth, it comes down towards the earth under the influence of gravitational force or due to the force of gravitation of earth. This we know. We also know then when object is coming down towards earth, it has some velocity, and this velocity keeps on increasing, and the change in velocity is uniform. Not the velocity is uniform, change in velocity is uniform. When the change in velocity is uniform, there is an acceleration, and this acceleration is known as uniform acceleration. That is the motion of any object from top to bottom. When it is coming towards the earth, it is uniformly accelerated motion. This motion is known as uniformly accelerated motion. And we also know that this acceleration, which is due to the gravity of earth or the gravitational force of earth, is known as acceleration due to gravity. And this acceleration, it is denoted by small g. It is similar to A, which is normal acceleration, but this acceleration is particularly due to the gravitational force of earth. That's why a separate symbol is given, and it is the acceleration due to gravity, and this is the normal acceleration. So these things we know. Now we also know, we have learned about the equations of motion given by Newton. Newton's 3 equations of motion we know, and these equations of motion are, I am writing again, V is equal to U plus AT, then S is equal to UT plus half AT square. All of you know these equations. And then V square minus U square is equal to 2AS. These are 3 motion of equation of Newton. V is final velocity, U is initial velocity, A is acceleration, and T is time, and this S is displacement or distance. So these are the symbols. One thing more, that these 3 equations of motion are valid only for uniformly accelerated motion. That is, the acceleration should be uniform. These are not valid for non-uniform motion, non-uniform acceleration. These are valid for uniform acceleration. That is, the change of velocity should be equal in equal time interval. That is uniform acceleration. So these equations are valid for uniform acceleration. Now we see if the g, which is acceleration due to gravity, is uniform or not uniform. This g is also uniform acceleration because the value of g is constant on the earth surface and near the earth surface, and it is 9.8 meter per second square. The unit is same as of A. So these 3 equations are also valid for this acceleration due to gravity. We can use these three equations of Newton for motion of objects under the influence of gravitational force of Earth, but with a slight modification. Now we will see what are the modifications of these three equations. V is same, U is same, time is same. This A is changed. The normal acceleration A, it is changed with the letter small g, because g is the gravitation, is the acceleration due to gravity. So this A is changed to g, and one more thing, this displacement. This displacement normally in these equations is horizontal displacement, but here under gravity the displacement is vertical. All the objects, they fall on the earth vertically in the straight line. So it is height. So this S is changed by, modified by height. Instead of S, we write height with the symbol small h. These two are the changes we have to do in these three equations when we use these equations for motion of objects under the influence of gravity. So I am writing these changed equation for this purpose. V is equal to U plus GT. The second will be H will be equal to UT plus half GT square, and the third will be V square minus U square is equal to 2GH, where H is the distance or the height, G is acceleration due to gravity. So now we have these three equations of motion of Newton for this motion of objects under gravitational force. So now we will study, we will do these three numericals which I have written on this side of this board, and we will done one by one. One more thing, before solving these numericals, we have to keep in mind. First is the motion of the objects can be, this ball can come down towards the earth. So the velocity is in this direction, and g, small g is also in this direction. The earth is pulling this object towards itself. So we will take 9.8 meters per second square in plus sign, in positive sign. This g is in the direction as the direction of the velocity when this object is coming down. This is one thing, taking g positive when the object is coming towards the earth. This is one thing. The second thing, when the object is coming, so I will write here falling down. When the object is falling down, what we have to keep in mind, first this g should be positive, and the first we can write g should be positive. The second, we can say, suppose this is a building. This ball is kept on the top of the building. So the initial velocity here is 0. So in this case, u will be 0, and v will be when this ball touched the ground, before touching the ground, this velocity will be v. So v we can calculate. But when an object is falling down, the initial velocity u is 0. These two things have to be kept in mind. When the object is falling, g should be plus 9.8 and u should be 0. Now the second case, when the object is thrown up. Second case is, then also these equations are valid when the object is thrown up. Suppose this is the ball in my hand, I thrown it up towards the sky. this ball is thrown up. So here I have to use my muscular force to throw it up. Some force is there and this force change into the velocity. So here the velocity should be given in the numerical. This is not 0. Here the u is not 0 when the object is thrown up. But what about v? Here v is 0. Why v is 0, the final velocity? Because once the ball is thrown up, when it reaches a maximum height, it stops for a moment and its velocity become 0 and then it started coming down. So in that cases, when the objects are thrown up, two points should be kept in mind. First, u is not 0, v is 0 and this acceleration due to gravity should be taken in minus. This is minus ms square because the velocity is on the upper direction but then also the g is in the lower direction because the earth is pulling this object towards itself if it is going up then also. So here the velocity, the direction of velocity and direction of g, they are opposite to each other. That's why here the g should be taken into minus and v should be taken at 0 and u is not 0. These 2-3 points we have to keep in mind before solving these numericals. Now we will see these numericals one by one. So I am changing these equations for this is also g, this is also g and this s should be h and this s should be h. So now these three are our equations of motion for gravitational force. So first, a ball is thrown vertically upwards. So I will draw a diagram. This is a ball. It is thrown vertically upwards and with a velocity of 49 meters per second. So this velocity is u or v? First of all, I should write what is given. The given parameter I should write given pen is not working. So given parameters, first we should write u, what is v, what is g and what is given. Thrown vertically upward with a velocity of 49. I have told you when something is thrown upward then u is not 0. So here u is 49 meter per second. So we have to calculate maximum height. We have to calculate height, what is height, and second time. We have to calculate time also. So here v is 0. When something is thrown up then u is not 0, it is 49 and v is 0 and g is minus 9.8 meter per second square. Even g is not given but we have to take by ourselves 9.8. If it is not given, sometimes in the numericals it is given take g as 10 meter per second square. Then we will take 10, otherwise we have to take 9.8 meter per second and as the object is thrown up, we have to put minus sign before this. Now we know v, u, g and h. And h we have to calculate. So first of all we will see which equation is to be used to calculate h. So h is there in these two equations. Here we do not know the time. Time is not given, so we cannot take this equation. So h is also here, so we can take this equation to solve, because we know v, we know u, and we know g. So h can be calculated very simply. So first write this equation here and then start filling the given parameters. So I am writing this 2 into g is minus 9.8 into h. I have written this on this side as we have to calculate h. Then v square is 0. So I will write 0 here minus u square. U square is 49 into 49. U is square, so 49 into 49. So now, what is this? Multiply this by this. One 19.6, and it is in minus. 19.6 h is equal to minus 49 into 49. Is it correct? V0 and this is u square. So h will be minus 49 into 49 divided by minus 19.6. This will be cancelled, and what is left? 0 is here. So this is how much? When we cut this, it will be, how much this will be? When we calculate this, you calculate this, I have calculated, you will get 122.5 meters. This is the height and this is the answer of the question. You cancel this, cut these two, then multiply with this, and you will get the answer 122.5 meters, which is the height of, maximum height to which it reached. So this is the height. Now we have to calculate total time it takes to return to the earth. Now we will calculate time also. So for time we will take which equation we have to take? We can take this simple equation. Now we know v. No, this is not height. What is that? V in 122.5 meter is height or what? Yes, it is height. So for time we will take this equation, v is equal to u plus at. V we know is 0. 0 is equal to u is 49 plus g is 9.8 into t. So what will be it? So minus 9.8 t will be 49, and here we have to take minus. So minus plus minus, so it will be plus 49 and t will be 49 upon 9.8. So this will come to 4 seconds. When we cut this, it will come to total time it takes to return to the surface of the earth. No, not 4 seconds. It will come to 5 seconds. Yes, it will come to 5 seconds. So t is 5 seconds. But we have to calculate total time it takes to return to the earth. So first ball is going up, then it is coming down. So 5 seconds for going up and 5 seconds for coming down. So the total time will be 10 seconds. And the answer is 10 seconds. So this is how first numerical is done. Now read the second one. Second is a stone is released from the top of a tower. So here the stone is coming down. It is coming from the top of the tower. The stone is coming down of the height 19.6 meter. So the height of the tower is 19.6 meter. Calculates its final velocity just before touching the earth. As the stone is coming down, so u will be 0. When an object comes down, the u will be 0. We have to calculate. U is 0. G is plus 9.8 meter per second square as it is coming down, and height is 19.6 meter. So we can use this equation. As we know height, we know G, we know U, and we will calculate. So we can write it V square is equal to U. We will shift on this side, but it is 0, so nothing to write. We will write 2 into 9.8 into H is 19.6. So it is, when you multiply these two, it will be 19.6 into 19.6. This is V square, so V will be 19.6. These are two. So V square is equal to 19.6 square. So V will be under root 19.6 meter per second. So the final velocity in this case is 19.6 meter per second. G is positive, U is 0. We have calculated. So this is how this numerical is solved. Now the third one is a bit tricky. The third numerical is, you read it out. A stone is allowed to fall from the top of a tower 100 meter high. At the same time, another stone is projected vertically upward from the ground with a velocity of 25 meter per second. Now see, the stone which is falling down, one stone is falling down. For the stone which is falling down, we have height is 100 meter is the total height. Then for the falling stone, U is 0. We will calculate. Another stone is projected vertically up. Upward stone from the ground with a velocity of, its U is 25 meter per second. We will calculate and where and when and where the two stones will meet. When means we have to calculate time, and where means the height where the two stones meet. So first we can draw a diagram. Suppose this is the falling stone and the other stone meets, which is thrown upwards at this place to this falling stone. So this total height is 100 meter. We know it is given. They meet somewhere in between this total height. Suppose this stone which is going up, it travels a distance of x meter when it meets to this stone. Suppose this distance is x meter. So what is the distance left? This distance will be 100 minus x, as total is 100. Suppose the stone which is thrown up, it meets the first stone at a distance of x meters from the ground. Now the total is 100. So this stone will meet this stone at the distance of 100 minus x meters. So now we take, suppose, the equation, this equation we will take, because we have to calculate this h also, x, then u, t, half, g, everything else, and t we have to calculate. The time, when means we have to calculate time, and where we have to calculate this distance. So I am write this equation is written here, h is equal to, so in first case for falling stone, we will see here h, instead of h we will write 100 minus x. This is the height when it is falling, u, t. Here u is 0, so this expression becomes 0 is equal to half. It is coming down, so it will be minus 9.8 and t square. So what is this? 100x is equal to minus how much? 4.9 t square. So this is suppose first equation. Our first equation is where 100 minus x is equal to minus 4.9 t square. We have written this formula, half gt square, ut is 0 because u is 0, so ut is 0, half this g is as it is, no, this should not be, it is falling down, so it should be plus, half plus, so 100 minus x is equal to plus 4.9 t square. It is falling down, so we will take 9.8 as plus. So this is suppose first equation. For the second, which is going upward, this is one case. For the second case, this is height is x. We have written here u. How much is u is here? 25. 25 is u. So in this equation, 25 into t plus half g is minus 9.8 because it is going up. So g is minus 9.8 into t square. So it will be 25t plus 4 minus 4.9 t square. So now this is the equation. Suppose this is second equation. Now we sum both the equation, then what will be, if we add these both equation, it will be 100 minus x plus x is equal to 4.9 t square plus 25t plus minus 4.9 t square. Is it clear? So I have sum up both the equations. Number one is 100x is equal to 4.9 t square plus this one x is equal to 25t plus minus 4.9 t square. So this is minus, this is plus, so both are cancelled. This is minus, this is plus, both are cancelled. So what is left? 100 is equal to 25t. So t will be 100 upon 25 will equal to 4 seconds. So when they meet after 4 seconds when it is dropped from here and it is thrown from the bottom. So the time is 4 seconds. After 4 seconds, this is the answer of when they meet after 4 seconds. So now where they meet? So we should know the value of this x. We can calculate the value of this x by having this, any equation we can take. Now we know t. So we can take even this equation, any equation we can take. Now we know the value of t. So we can calculate the value of x. So I am taking this equation. 100x, 100 minus x is equal to what was that equation? 4.9 t square. We have this equation. Now we know this is 4.9 into 4 square. 4 4s are 16. So 100 minus x is equal to this much, 4.9 into 16. So x will be, minus x will be 100 minus 100 into plus 4.9 into 16, and it will comes to 21.6 meter. If you calculate this, it will come to 21.6 meter. That is, this distance is 21.6 and it is 100 minus 26. What is there? It will be, I think, 78.4 meters. So they meet at 21.6 meter above the ground and 48.4 meter down the ground. So 100x is equal to 49 into 16. Is it? It is okay. So t is 4. So it is 16, and to solve this you will get 21.6 meter. So this is how this is calculated. I have taken minus 98 here. So when it is thrown up, we have to take minus 98, and when it is coming down, we have to take plus 9.8. So this is how these numericals are done. You do all the other numericals which are given in NCERT and from reference books. So in the next video, we will take some other topic from this chapter, gravitation. So this is all for today. Thank you.